the first round was really friends and family. I mean, like 98% friends and family. So as we've matured, VC money has come in more than friends and family, just because the checks need to be bigger and that sort of thing. But yeah, I mean, bootstrap, don't raise on hype, raise on what you've done. That's what I'm trying to tell everybody.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Trevor Smith, President and CEO at Atomic-6. Trevor, thanks for chatting with us today.
Happy to be here, man.
Yeah, I'm super excited about this. You are doing some awesome things. But to get it started off, you have quite a diverse background. Share with the folks how you found yourself, as President and CEO of an awesome space company.
I grew up, I'm a very risk tolerant person. We had a business coach. She'd been doing it for 35 years. You do the personality profile thing. She said, Trevor, I've never met anyone in my entire career that scored higher on the risk tolerance profile than you have. I said, well, I love things that go fast and I can hurt myself on. I grew up racing dirt bikes and cars and all that stuff. So how I got into this was, hey, let's go look at things that go fast, fighter jets and rocket ships and all kinds of things like that. But I guess before that, to your point, I got a degree in commercial real estate, if you will believe that or not. My degree is in real estate finance, with an emphasis on commercial. And I moved to Atlanta, was a commercial real estate broker, office and warehouse for 6 years. And in that time, met my co-founder, and he had a unique way to basically solve the problem that the composites industry has had since the inception, which is how do we get aerospace grade level composites at not necessarily automotive level manufacturing, but a lot more volume, a lot cheaper, a lot faster, right? So our claim to fame is we have, the metaphor I use is a glorified muffin pan, because everybody knows what a muffin pan is. It's a mold, right? So you can make muffins in your mold. We have a two-sided mold. So think about stacking one muffin pan on top of another. And we can manipulate materials in a unique manner with this mold design. So it's a very special mold. And we are agnostic to the raw inputs. So some people think we're a material company. We don't actually make the raw materials. We utilize those materials in a unique manner in our autoclave, which is basically it's a pressurized oven. We use nitrogen in an inert gas, so we don't blow ourselves up. But we pressurize these composite structures in a unique manner under high pressure, and out comes these really cool high performance material systems. Is that enough of a high level to get started?
Yeah, no, that's great. And so from real estate into the muffin pan.
Well, so yes, and so not that I'm comparing myself to Elon, because I would never do that. Although my COO's previous boss was Elon, I started a commercial LED lighting company the same day I started Atomic-6 to get Atomic-6 off the ground. So I go to my wife and I say, hey, I've never had a startup, but I'm going to do two at the same time. One of them, once it's working, will pay for the other one that I really want to work, right? So I sold lights to basically pay for the R&D for Atomic-6 for the first 3 years of our existence, while my real co-founder, which is my wife, paid all the bills while I was off spending all the money I was earning from one startup and putting it into a new one.
So you just decided to make that you have some unique go-to-market with it, or unique technology, or there was a need and you were filling
for the light bulbs or the carbon fiber?
The light bulbs. I mean, to start that, I mean, obviously it was successful because it helped fund you guys starting.
It did. I actually made more money selling lights than I did in real estate. But I focused solely on the commercial lighting aspect because I had a Rolodex of commercial people, and basically took my financing degree and said, how do we turn this lighting pitch into a dollars per square foot, which at the time in 2016, not a lot of people were doing. And it really resonated with the customer. So that's kind of how that worked.
Fantastic. Well, now that you're at Atomic-6, for those that don't know, what is Atomic-6 about? Obviously, it's materials, but tell us kind of the mission and what you're trying to accomplish.
Sure. So I like to say everything from the ocean to the orbit, ocean to orbit, right? So advanced lightweight structures, and we found the most traction in the most extreme and demanding environments. So space, hypersonics, and high performance aeronautics. So like unmanned fighter jets or hypersonic Mach 5 aircraft. Hermeus is a client of ours. If you've heard of them, they're a pretty big startup here in Atlanta as well on the hypersonic side. And then in space, we've got so much traction on the space side with Space Force doing lots of different things with power and protection. And we can dive into that a little more in a minute, I guess.
Yeah. So very cool. And so as you've set off, talk to us about some of the, I'd say, groundbreaking solutions or use cases that you guys have developed as you have moved forward through the journey of your Atomic-6.
So our first big aha, holy cow, how did we do this moment? We submitted for an SBIR. I'm assuming your audience knows what the SBIR SBIR program is. We submitted for a direct phase 2, and that was to build a new type of micrometeorite and orbital debris shield. In short, MMOD shield or debris shield for space. I didn't know what those acronyms were, but I said, well, this technology hasn't changed since 1940 when Fred Whipple invented it, and that's what's protecting the International Space Station today. And I said, let's go for it. Let's see what happens. So we submitted. We ended up winning the direct phase 2, not really knowing quite what we were doing, but then we started to do a lot of homework, and we put together a material system that was not metallic like today's debris shields are. And a friend of mine, Commander Chris Hatfield, I don't know if you met him or know of him, but he's he's the first Canadian commander of the International Space Station. And he said, Trevor, I would have to go on spacewalks and replace these Whipple shields that were like getting hit with the debris. And I said, well, how often is the ISS getting hit? And he said, it sounds like rain on a tin roof. It's constant. So you can think about going outside into space with all this debris coming in. You don't really have protection in your spacesuit, but you've got to stop the space station from getting, penetrated. So he's out there swapping these things around. He said, I'm going to sign your first shield. So he actually signed the very first shield that we made, and we shot it, and it worked. Like nobody thought it was going to work, but it worked. And so we've iterated through that, and now we basically have the lightest, thinnest debris shield that Space Force has ever seen.
How did you, like, just the physics behind it? How did you come up with this? Like, how was?
So we, on the contract, we actually asked NASA because there's some unique software for modeling this type of impact because the physics are crazy. So we sent them our idea, said, hey, we think we're going to put together these things in this order and tell us if we're in the ballpark. And they were like, this isn't going to work. So then we shot it just to see what would happen. And it worked. And then NASA was like, can you help us with our modeling and simulation? And so we're like, yeah, this would be great. Let's figure this out. So the physics, you think about, I'll give you a real world example. So I took one of these shields. I have a Glock. I took it to the gun range because, I'm a little bit of a redneck, but this is the shield. This stops 3mm aluminum ball. This was the impact right here, moving at Mach 21. So 17,000 miles an hour. Think about taking that impact, right? That's a really fast moving bullet. So I thought, surely my 9mm is going to be stopped, right? So I took it to the range, I shot it. It went right through. Didn't even deform. It just like a hot knife through butter, went right through. And I was like, why is this? Apparently there's some non-Newtonian physics at play at certain speeds. So think about when you shoot a supersonic round versus a subsonic round into water. The slower bullet, the subsonic round, will actually go 10 or 12 feet deep, whereas the supersonic round goes 1, maybe 2 feet deep. It's kind of like slapping the water with your hand versus slowly inserting. Terrestrially, bullets just don't go fast enough for our space shield to work. Who knew?
That's great. Show me that platform again for folks. If you look on the back side.
Oh, yeah. Yeah, and I'll show the video. So this is the backside. It's smooth. But yeah, it's about a 1/2 inch thick, and it weighs 2 kilos. And so I'll show you. You said you wanted to see the video, so
yeah, I think it'd be great. Yeah.
It's awesome. So I'll show you 2 videos. The first one will be an impact of an aluminum ball moving at Mach 21 on an aluminum block. So basically a metallic shield. So you can see the bullet coming in. There's a shock wave on the right side and hundreds of pieces of debris flying out on the left side.
How big is that aluminum block again? Sorry.
It's about 1 inch thick. A solid, like, inch thick monolithic block. And then the ball is 3mm. And so you'll see hundreds of pieces of debris and an explosion of plasma because there's so much heat that gets built up with that bullet passing through. The barrel of the gun's about 200 feet. So what's interesting about our debris shield is same video. The top video is the aluminum you just saw. The bottom is space armor, that shield that I just held up. There's no post-impact ejecta that we can see, and this is 1 million frames a second. There's no post-impact ejecta that we can see on this thing. So we were recently awarded a tactical funding increase for space armor, and that TACFI is designed to get space armor through qualification for first flight. And the Space Force has a very large asset going to geosynchronous orbit that they want to protect. And so that's the idea: is we'll finish the TACFI, get it qualified for space flight, and then go protect this high value asset.
Oh, so have you talked with Matt Kuda and the Voyager Now Technologies group, who's on the next replacement for the space station?
What companies with that?
It used to be Voyager Space. They just changed their name to Voyager Technologies, but they
Oh, I didn't know they went to Technologies.
Yeah, they just changed. They're making a run, an IPO run, but.
Yeah, we've actually spoken to all 4 private space stations being built. So Gravitics, Axiom, Sierra Space, everybody.
Are they?
Yeah, actually, Axiom asked if we could put this in spacesuits, so astronaut suits, because right now there's no way to protect it. So with our shield, it's actually formable, just like a chest plate you would see, in a typical police or military standard chest plate. You can form this chest plate to protect the astronaut inside the suit, which would be really cool, and we should definitely do that. But yes, we are actively pursuing opportunities to put these on human-rated spacecraft. Those will be a bit thicker because the ISS is rated for 12.5 millimeters, not the 3 millimeter that I showed you, but we have actually tested a 12.5 millimeter hit as well, and we survived that shot as well. It didn't penetrate.
How much bigger do you have to go just for the bigger mass?
It's probably 4 to 5 times thicker, just because the R squared energy that you're having to absorb is pretty crazy. Just that 3 millimeter hit is 50% more energy than a 50 cal armor piercing round.
Wow.
From a 3 millimeter ball.
It is moving pretty fast.
Yeah, it's moving. It goes from 0 miles an hour to Mach 21 in 16 feet, overcoming 1.3 million G-forces in 16 feet. That's the bullet. It's wild.
That's actually pretty good. We want to go talk to the guys that made that gun.
I was telling one of my buddies who's like a world-renowned sharpshooter, and he was telling me how fast some of his bullets have gone, 3,000 feet per second. And I was like, well, I stopped blah, blah, blah. And he goes, holy cow.
That is very cool. All right. What else have you guys done? I know you got some other things cooking.
Yeah. So the other big space product that we have is called Lightwing. It is a redeployable solar array system. So redeployable is important for lots of different things. Most people think about a solar array where you pop it out, it stays there, it captures the energy from the sun and helps power the spacecraft systems. Well, what happens if you want to do RPOD missions, rendezvous, proximity, operations, and docking? Lots of military con ops open up when you can make your satellite not look like a satellite. So if your arrays come in, you just look like a box floating around in space. You don't really know what it is. If you need to dock with someone, you want to pull those arrays in, dock with them, makes it much easier. So it lowers the jitter of the spacecraft. If you want to do a lot of different things, one including high resolution image. So if you have a camera, you really need a high res image. You pull those arrays in, you can take that image. So the reason you pull the arrays in is because you lower your center of gravity and lower the jitter of the spacecraft. Think about like a sailboat. If you pulled your sails in, the boat's not moving around as much, right? And then if you need what's called a high delta V burn, or you just got to press the gas pedal and go somewhere real fast, your arrays today would rip off because of that force from the thruster. It would rip those solar arrays off. So you want to retract those arrays, press the gas pedal, get to where you're going, and then redeploy. So I have
in and of itself doesn't sound that challenging. Is it more mechanism or is it more materials? Like, how does the material piece come in?
So what's unique about our system is we have a novel hinge design. So when you look at the deployable solar arrays today, minus what's on the ISS. So what's on the ISS is called a roll-out solar array. So it is deployable and it rolls out. And I think they've retracted it once or so, but no one really offers a off-the-shelf retractable system. So what makes it difficult in space, you're dealing with temperatures of, plus 130 C to minus 80 C, and metal hinges and springs really have a tendency to lock up, especially because they're under what's called biaxial stress. Literally, it's a scissor lift, right? So when you're deploying this array, you've got a scissor lift going like this to get the thing out. We have a hinge mechanism that is memory shaped. So think about the slap bracelets you used to put on your wrist in the 90s. It's memory shaped. So it wants to be in one direction or another. So this hinge allows us to deploy the array, because we have a deployable, the other video I'll show you, we have a rendering of our system deploying. Okay, so you have your deployer here on the left, and these black pipes, those are the deployable masts. So they actually can roll up just like a tape measure. And then on top of that, you basically have these solar panels, and in between the panels, you have these hinges. So our hinges are not metallic springs that sort of scissor lift. It's a shape, it kind of looks like a half pipe. And then as that panel gets stretched out, the half pipe gets stretched and puts tension on those solar backsheets, allowing you to get really tight backsheets, but very, very thin. So this is what the mast looks like. So it's very thin. It's about 9/1000ths of an inch thick, but it's flexible. You can roll it up like that, just like a tape measure. And then you have the backsheet, which is what the solar cells sit on. So this is what one of the backsheets, just an example, looks like. Very, very thin, very flexible. It weighs nothing. It's like thick paper. But that novel piece that I was talking about is this hinge right here. So as that deployer goes out, it pulls on those panels and tightens everything. So when you want to retract, this just wants to go back in the stowed position. It wants to go back in. So that allows for very safe retraction. So not only have you designed a much, much lighter weight system, you've also designed out a lot of the complexity in the mechanical systems by making this like an all composite, very memory shaped thing. So we've got a couple of different programs with NASA and others, and we're hitting metrics on the watts per kilogram that NASA doesn't even believe, because these systems are so lightweight due to the nature of the design of the structure, right? So we're not putting all these metal springs and hinges and thick back sheets where the solar sit. We're using smart, simple engineering to our advantage.
And the material technology, is this similar to the space armor technology, or completely different?
Very different. You would not, this would not stop a micrometeorite by any chance.
Yeah, but like to come up with the materials and the ideas to do this, just completely different, just a whole different like engineering effort and physics effort.
Totally different problem set, totally different material set. Yeah.
I mean, that's pretty impressive for your physics and engineering teams to be able to do that.
Well, so I showed you Lightwing. We were talking earlier about some fun projects we were pursuing. So we recently announced a project with Starpath Robotics. We are building a demo for what they have called their Power Tower. It is a deployable vertical solar array tower that will go on the lunar South Pole, capturing power. They plan to mine the lunar surface for liquid oxygen. In order to do that, they need a lot of power. So think about an NBA basketball court, but 1.5 NBA basketball courts vertically standing on the lunar surface. That's how big this system will be. It'll be probably 150 kilowatts. To give you an example, most satellites might fly a 1 kilowatt or a 5 kilowatt system. This will be like a 150 to 200 kilowatt system. And so we're designing the mast, which is that little black thing I showed you earlier. So this was the Lightwing mast. In order to do a structure like I'm talking about, I have to stand up so you can see this. The mast is much bigger. They're not glued together yet, so but you can see that.
That's strong enough to go up, a basketball court and a half and hold.
There's a lot less gravity on the moon.
There is.
Yeah, but
less wind.
And less wind. Yes. So the answer is we think so. We'll find out. I don't know. But it'll end up being 150 feet tall.
That is pretty impressive. So from these materials, is there anyone else participating in kind of these, the composites you're putting together to compete in this space, or is this all pretty much greenfield for you?
On the deployable solar arrays, obviously there are existing competitors, but there's really not that many globally speaking. I mean, you have Lockheed, Redwire, Northrop, Airbus, but there's just not that many because it's a really, really difficult thing to build. And fortunately, my chief operating officer, I think I brought him up earlier, but he designed the propulsion system for Starlink. So Elon and Tom Mueller personally interviewed him. He designed the propulsion. He built 1010 and 2, and then helped design about half the factory for all of Starlink, and then put up, he led the team that put up 1,400 Starlinks during COVID. So at one point in time, my chief operating officer was responsible for about half of all orbiting satellites. So to get to your question, I have a unique IP that allows us to do things from a performance perspective, and I've hired the right talent to go after the thing that we need to pursue. Right. So Christian, he's actually here in the office today with me, but he normally he lives in Redmond, Washington. But I've got some really incredible talent on our team. I'm not the engineer, Dave, as we obviously know already. But I actually have helped.
Junkie.
Yeah, I have helped on a few of our patents, so I'm a little smarter than I look, maybe. But yeah, it's a unique team. We're hungry. We've done more in revenue than we've raised. And that's an incredible place to be as a hardware manufacturer in the aerospace industry.
How did you fund? So you funded it with, your company, and you've raised money. So you've gone into, venture capital, or I imagine. Talk to me about that.
Yeah, we've got some VC money.
How hard that's been? Is it, that's oftentimes I've heard in the past. I think it's getting easier, but raising capital for hardware.
Oh, I'm glad you bring that up, because yesterday at 4:59 p.m. we decided we were going to go raise a Series A. So if there are any VCs listening to this, my doors are open now. We're ready to talk. So to back up a little bit on the funding, we were extremely fortunate. I say we, it was just me on the team, basically, because my co-founder had a full-time job. I raised the first round in 2021, which was arguably the best year ever in human history to raise funds, which is great in 2021. But then you look, it got harder and harder, and you see a lot of startups, they raise a down round, right? So the valuation went down. It's much harder to do. We've raised 3 rounds, including, the one in 2021. We've never had a down round. It's always been up, and we've done more in revenue than we've raised. And I do that methodically because I don't look for a headline that says, hey, we raised this big amount of money. Now we got to go figure out what to do with it. I raised just enough to get me to that next milestone that I saw. So I could, you're taking a bet on yourself, right? Instead of betting on somebody else's money. So I would encourage, the year 0 founders who are looking to raise their first round, bootstrap as long as you can. But when you get something that really makes sense and that can ignite an investor, then pull the trigger. But the first round was really friends and family. I mean, like 98% friends and family. Yeah. So as we've matured, VC money has come in more than friends and family, just because the checks need to be bigger and that sort of thing. But yeah, I mean, bootstrap, don't raise on hype, raise on what you've done. That's what I'm trying to tell everybody.
Yeah. So, I mean, you're right. That time frame for, capital was amazing. And you talked about, the down rounds, just almost regardless of the industry, right? People were seeing that valuations are coming down big time, which crippled many startups. But have you seen a change in the venture capitalists that are interested looking at, defense tech? Because I got the impression in like 21, there was not much interest in defense tech. The time to horizon to be able to double, triple their investment and get the right, rate of return was not there. What do you think's changed?
I think defense tech got, hot late 22, maybe 23. It's still hot, and now with our president, it's going to be much stronger than ever, just because of that whole program and what they're trying to do, especially with space. Right? I mean, Elon's there, and I foresee defense investing not going down. I thought it might go down depending on who gets in the office, but now I don't think it'll be going down. I think it'll be easier to raise, and especially if you're in the space industry. I mean, I think there's something like 10,000 satellites right now orbiting the Earth, and literally everyone I speak to is like, it's inevitable that we're going to have 100,000 satellites like in the very near future. So from a investing in defense, and especially space defense, it's not going anywhere anytime soon.
How about working with the government? As you're starting now, are you selling directly to the government, or are you mostly working with other, commercial entities that are providing services?
So if you look at Atomic-6 on the space side, we're really a subsystem provider. I don't build a spacecraft, but I can help build all the spacecraft, right? So every spacecraft I've ever seen had solar arrays on it. Not every spacecraft has a debris shield on it, but I think it'll become more and more of a thing because of this debris issue that is going to continue to happen. So to answer your question, we would actually sell into a prime, right? So Lockheed or Apex Space or whoever's building the bus is building that, and then they would contract us through. They either learn directly from us or they've talked to our technical point of contacts at Space Systems Command or whoever it is that say, hey, you know, those guys at Atomic-6, they're doing something pretty unique. You should talk to them, right? So I believe in building stakeholder value, not just with commercial customers, but spending a lot of time on Space Force and Air Force bases. I go to LA all the time. I'm out at Peterson in Colorado Springs. There's a heavy space presence out there. So while we don't sell directly into the government, we do benefit from the SBIR program. But eventually, as we get bigger, we will sell into, the primes, if that makes sense.
Yeah, absolutely. Well, it's also, obviously, I think critically important for the government to understand what capabilities you have. So when they push something down to their primes,
right,
that relationship.
Hopefully we can be there saying the requirement should look like this. And we just happen to be the only people on planet Earth that can make that thing.
I was going to ask you if you'd worked with Ian over at Apex. I've had him on the podcast, but the buses they're making are awesome.
Super cool. Yeah, we're I've toured their facility. I've talked to Ian. My COO knows him really well. So yeah, we'd love to work with Apex, Ian, if you're listening. But yeah, we've definitely toured their facility. They got something cool going on over there. And the vibe table they have is insane. It is just massive vibe table. It's so cool.
Yeah, I mean, there's just so many cool space companies, like with what you're doing. It's just fantastic. Where do you see, are there any new technologies that are a different, or different capability sets? You mentioned two, that you're pursuing that you can talk about, new composites or, use cases for.
Yeah. So Hermeus, I mentioned them earlier. They are building Mach 5 aircraft for both DoD and commercial, eventually commercial, but you stand it up through DoD. We got a director phase 2 to build a hypersonic radome for one of their vehicles. So this is sort of my, if the founders out there are listening, this is my SBIR playbook. It's all about incentive alignment. So I have a customer I want to pursue, Hermeus, and I say, hey, Hermeus, what's something you really need help with that we could help you with that might be a difficult challenge that you want to see built? Okay, we need a radome. Great. So I call the Air Force. I call my Air Force technical point of contact, and I say, hey, would you guys be interested in Atomic-6 building a hypersonic radome for Hermeus? Would that be of interest to the Air Force? And they said, absolutely. So what I said was, okay, Hermeus, let's sweeten the pot. We're going to make the exact structure you need, but I want to increase my odds of winning this directive phase 2, which are really low probability odds of winning. So I asked them to put some skin in the game. So they offered up a check, undisclosed amount. And so basically, they're putting a check on top of the directive phase 2 contract as an incentive to show the Air Force that they're serious, right? So they want to see it built. The Air Force wants to see it built. Hermeus puts money in it, and they actually get a huge return on that money because they're leveraging that DoD dollar. That's how every SBIR submission should look. So that's on the hypersonic side. Very, very fun things working on there. And then on the high performance aeronautics, you got to get this guy on your podcast. Clay Crochelle, he used to work at Shield AI. He sold the VBAT. He was the head of sales, like the entire Western hemisphere for sales for the VBAT. He started his own company called Delta Black, and they are building a Group 3, 330-pound hybrid UAV system. They have charged us with building the entire composite structure for that bird. So fuselage, wings, the whole thing. We've never built an entire aircraft. We've only been charged with building parts of an aircraft. So this will be our first opportunity to build a full aircraft, 17-foot wingspan, 1,600 nautical miles. So you could take off on a Monday and land on a Wednesday. That's the range that they have in this thing. It's crazy. And he's a good friend of mine. And we actually have some mutual investors, so it works out really well. But yeah, it's a really, really cool thing that we're working on. I'm excited because it's a full aircraft, and we're hoping to fly that thing in the coming months.
That's just fascinating how many different things you're looking at. How big is your company?
13 full-time today. We have more projects than people, so I got to fix that.
That is crazy. So I'd say let's go back just kind of as your journey and, as you guys are doing great things. And what would you offer for some like leadership lessons or advice for new entrepreneurs? You gave some with how to, tackle the cyber world, which I haven't heard that before. I think that's fantastic, strategy to secure, well-placed funded, opportunity.
I was right before I jumped on with you. I was doing that exact cyber playbook with Starpath, the Lunar mining company. Said, hey, we're doing this NASA phase 2. They want to see the same thing you want to see. Like, let's put them together. And then I jumped on the call with you. So like, it works. I would tell founders, if you've never raised or, you have raised, but you've never done a lot of homework, go read Venture Deals by Brad Felt. I probably say that at least 3 times a day to somebody. It's an incredible book. I learned more from that book over a weekend than I did hiring a broker, which was much more expensive than the $20 book off Amazon. So do that. If you're in hardware, keep a long runway because things just take longer than you think. Hire slow and fire fast. Hire really slow if you can and fire very fast. Yeah. And then we did this recently. It wasn't how we started, but we should have started the company doing this. Just a business strategy where you take 2 full days and you go through what are your opportunities? What are your markets? Where does your product best fit? And just really sort of red team, blue team the opportunities. Like no bad ideas, throw everything on the wall. And we learned that the market for carbon fiber golf clubs is bigger than the market for hypersonics. Who knew? But we had this strategy day and we learned about different opportunities. So I would encourage, a founding team to really do due diligence and figure out what market may best fit you. Like when we started Atomic-6, I didn't know that solar arrays were going to be our thing. I was selling into tractor trailers and 18-wheelers because I thought we'll increase fuel efficiency and payload. And we're still increasing fuel efficiency and payload, but we're just doing it on aircraft and spacecraft instead of 18-wheelers. So I would encourage the team to do that.
That's great advice. Well, if people are interested, I've got, a lot of different types of listeners. And I just look at what you're doing. There's so many cool opportunities, it sounds like. How would they best follow what you're doing and get a hold of you?
I live on LinkedIn. So I think my LinkedIn is just Trevor Smith something. But if you go to Atomic-6, you can find me. We do post what we can on LinkedIn. So we're pretty active there. And then our website is atomic-6.com. We also own spacearmor.com. We bought spacearmor.com. It just redirects to our website, but yeah.
When you spin that company out, then you've got it set up.
Yeah, exactly. So there's LinkedIn is really the best way to get a hold of me.
2 questions then to wrap this up. Where do you see yourself in 5 years? And then what legacy do you hope Atomic-6 leaves behind in, I'd say, the defense and material innovation space?
Sure. So in 5 years, I view Atomic-6 as this fun incubator studio type company at its core. And then at its core, we come up with really unique product ideas like deployable solar arrays or debris shields or some new type of aircraft. And we're coming up with these new cool ideas that become companies themselves. That allows me and my unique team who don't want to be making the same thing over and over again to keep innovating and sort of changing and shaking the snow globe every day, as I like to call it. So in 5 years, hopefully, we'll be much bigger than 13 people and maybe I'll have a fun, fast car one day. That'll be cool. And then what was the second question?
What legacy do you want Atomic-6 to leave? Defense and innovation space.
I think leave is the wrong word. I want it to exist. I don't want it to go away, right? So whether I'm here or not, I hope that the core of what we're trying to achieve here continues to support our warfighters however we can. And I think the best way to support the DoD and our warfighters is to make sure the things that we're building are in genuinely dual use. And I'll give you an example. So there are 400 million guns that the citizens of America own, which is, I think, 10 times more than the US military owns. Like from a gun perspective, it's like a 10x. Imagine if no citizens in the US bought a gun, how expensive those military guns would be, right? So you think about us building for commercial stuff, right? So like we can buy down the risk and buy down the price because we have such a vast commercial opportunity. And then we can sell that into the government and the taxpayers get a much better value for their dollar instead of going, hey, we're going to do this cost plus thing and we don't know how much it's going to cost. And the more it costs, the more we make. And we're really not incentivized to make it any cheaper. I want the best thing for our country. And I think long term, we'll be able to keep innovating, whether it's space or aeronautics or maritime, whatever it is. I hope we're on the forefront and leading edge of all those things, really challenging and accomplishing on hard problems.
I love it. Well, actually, I was going to say that wraps it up, but you are starting your own podcast. Give yourself a plug.
Oh, I haven't done this yet. So the podcast is called Full Burn. And as you heard, I'm sort of a speed enthusiast. And so I texted Carol Craig, the CEO of Sidus Space. It's a publicly traded space company. And I say, hey, Carol, I'm thinking about doing this podcast. Would you want to hop in a McLaren with me and let me ask you questions about your company? She's like, I can't say yes fast enough. So I've got 3 guests that'll be with me in Orlando that I'm interviewing. We'll hop in a car and we'll just hear about themselves and their company, but we'll be doing it in a $250,000 car as we go very fast down the interstate. So comedians in cars getting coffee kind of thing, but much faster and space and defense focused.
Hey, this has been so fun. I appreciate Trevor. Look forward to, let's do this again as you keep going. But thank you so much for your time. And when you come out to Colorado, let me buy you a beer.
I'll be out for Space Symposium in April.
Oh, well, we'll see you then.
All right.
Thank you.
Thank you.